we're going to modify this contract to make it a little bit more professional. It's not going to be end-to-end amazing, but it's going to be a little bit better, and you'll see why in a minute. So the first thing that we're going to do is we're going to look at some of these variables here. In particular, owner and minimum USD. Owner gets set one time in our contract here, and then it never changes again. Minimum USD gets set one time, even outside of the constructor. If we have variables that only get set one time, we can actually use some tools in Solidity to make them more gas efficient. For now, let's compile our Foundry contract and then deploy it to a JavaScript virtual machine. Remember, we can go ahead and deploy it right now. However, funding and withdrawing and doing any of the money stuff isn't going to work because, again, we don't have a Chainlink network on our JavaScript VM. So those aren't going to work so well. But for what we're going to do right now, we don't really care so much. Here's what we do care about. We do care about how much gas this costs to actually send. We do care about how much gas this costs to create. Right now, creating this contract costs about 859,000 gas. And we're going to add a couple of tricks right now to bring this number down. We're going to add some stuff back in a bit, which will bring it back up. But for now, we're going to learn some tricks to bring this number down. The two tricks that we're going to learn are the constant keyword and the immutable keyword. In their Solidity, there are two keywords that make it so that your variables can't be changed. And those keywords are constant and immutable. You can learn more about them in the Solidity documentation. If you assign a variable once outside of a function and then never change it, so if it's assigned at compile time, you can go ahead and add this constant keyword. We'll learn later about storage, but when you add a constant keyword, this minimum USD no longer takes up a storage spot and is much easier to read to. So now if we recompile this and we deploy this new contract, let's see if we saved any gas. If we look in the transaction logs now, we can grab the transaction cost of how much this cost to deploy. And let's compare it to how much it was before. Wow, we saved almost 19,000 gas. That's almost as much gas as it cost to send Ethereum. Typically, constant variables have a different naming convention. Typically, you'll want to do them all caps, like min, emum, underscore, USD. So all caps with underscores. So now let's just find minimum USD and replace that with all caps as well. With this interaction, we know that this variable is a constant variable and it's much cheaper to read from. Now, if we go ahead, compile this and redeploy in our Foundry contract, even though this is a view function, remember, view functions do have gas costs when called by a contract. As a constant variable, we can see the execution cost of this variable, 21,415 gas. So let's put a little note right underneath it. If we remove the constant variable, we delete this contract, we redeploy, we click Foundry, and we hit minimum USD again, we can now see how much gas this was cost if it wasn't a constant variable. We can see the gas cost did indeed go up. Now on chains that are much cheaper, this gas difference probably won't make it that much of a difference. But on more expensive chains like Ethereum, this is going to make a big difference. For example, on Ethereum, we can actually see current gas prices on Ethereum here. We can see that the current gas price of Ethereum is about 141 Gwei. So we'll go to our converter, Gwei to Wei, we'll copy the Wei price, times this, we'll get the gas price of calling our minimum USD, which is this number here, which if we put back in our Ethereum unit converter, we can see costs this much gas. And if we times that by the approximate current price of Ethereum, which is around $3,000, calling minimum USD as a constant is going to cost $9. Calling this at a non-constant is going to cost almost an entire dollar more. You can see how all these little gas optimization tricks are going to make your life a lot better. So let's keep this constant keyword in here. We'll learn more about constant and storage in later sections of this course. Now, as you're just getting started with this course and with Solidity, do not struggle and do not worry about making your contracts as gas efficient as possible. In the beginning, and especially right now, just write your contracts as best as you can. Once you get really good at gas and once you get much later on in the course and much more advanced with Solidity, then you can start going back and working on gas optimizations. But do not let gas optimizations hold you back, or if you start stressing over it, just let it go. don't worry about it and just write your code as best you can. So long story short, do not stress about gas optimizations right now. Now, another variable we only set one time is going to be our owner variable. Owner equals message.sender. We set this one time in the constructor. Variables that we set one time, but outside of the same line that they're declared, and we set them, for example, in the constructor, we can mark as immutable. Typically, a good convention for marking immutable variables is going to be doing I underscore so that we know that these are immutable variables. They have very similar gas savings to the constant keyword. Owner, of course, is a variable that we can't set on the line here because inside the global scope, there's no function going on. However, inside functions, because inside the global scope, there's going to be no message.sender. There's only going to be a message.sender when we're inside of a function. So inside here, we might say iOwner equals message.sender. And then of course, we'll scroll down and we'll change this require only owner now equals iOwner. Now, if we compile that and deploy it, we can see how much gas calling iOwner is going to be with the immutableness. We get 21,508, which we'll go ahead and copy for now. And we'll put right here, we'll say immutable. Now, if we remove the immutable keyword, let's close this, redeploy. Now, if we scroll down to iOwner, scroll up the logs, we go down to the call, we scroll down, we see the execution cost was much more. So we'll do double backslash, paste that in here, gas for non-immutable. So you want to keep some of these tricks in mind when it comes to storing variables. The reason that these two save gas is because instead of storing these variables inside of a storage slot, we actually store them directly into the bytecode of the contract. And like I said, don't worry too much about that for now. Later on in the course, we'll teach you more about storage and a lot of this low-level stuff that comes with these contracts. But for now, just know that these exist and they're nice gas savers if you're only setting your variables once.